We're now going to go on to talking about solubility, and so this links in quite well with our concept of aqueous solutions. And so first of all, you need to become very aware of the solubility table. So the solubility table is present in your data booklet, and it's going to be a lifesaver for you. It's very useful. And basically it's just this big table which tells you what is able to be dissolved in what. So it tells you the ion, whether it is soluble, and what the exceptions to the rule are. So for example, if we consider the nitrate ion, it is soluble in every circumstance because there are no exceptions to the rule. However, if we consider the chloride ion, we can see that the chloride ion is soluble. However, if we have AgCl or HgCl2 or PbCl2, they will not be soluble in water. And so that's because they are exceptions to the rule, which means that they will form our substances which are not dissolved. And so another important thing to note is that the lead halides, so for example PbCl2, which we just discussed, will be soluble in hot water. And so that also goes for PbI2, that will also be soluble in hot water. But in our typical standard temperature pressure conditions in the lab, they will not be soluble. Another thing important to notice is that calcium hydroxide is slightly soluble in water. So we say that it's an exception to the rule with the insolubility of the hydroxide ions. However, it is only slightly soluble in water. So it doesn't have a full extent of solubility. So that means that at very low concentrations, calcium hydroxide may be soluble, but at higher concentrations, it won't be soluble. And so with solubility, we can consider precipitation reactions. And so precipitation reactions are the combination of two solutions containing dissolved ions, and this yields a reaction depending on the reactivity of each ion. And so this is often true for acids and bases, but the products will be different. And so if the product of the reaction is not soluble in water, it will rapidly precipitate out, and as it's called a precipitation reaction. And so this will produce what is known as a precipitate. And so that's the solid which you can see which is sometimes formed in particular reactions. And so you must incorporate the solubility rules to determine if a precipitate will form. And so that's using our table from before. And so you can determine if the products, say for example you have AgCl as a product, you will know that that's an exception to the chloride ion rule, and so hence there will be a precipitate or an AgCl solid that is produced in the reaction. And so these reactions are always single or double displacement reactions. So an example which we have here is the combination of two solutions containing silver nitrate and sodium chloride. So if we have a silver nitrate solution, AgNO3, and we add that to the sodium chloride solution, which is NaCl, we then have this displacement reaction in which we produce AgCl and NaNO3. And so when we look at what our products are, we can see we've got AgCl and NaNO3. So we want to look at our solubility table to determine if these are soluble. So we can look for Cl, and we can see Ag is an exception to the solubility of chlorine ions, and so we know that AgCl is not going to be able to be dissolved. It will be insoluble, and so it will be a precipitate. Then our other one was NaNO3. So when we look for Na, we can see it is the sodium ion, it is soluble, and it has no exceptions to its rule. So that means regardless of what is bonded to a sodium ion, it will be soluble. So we know that that will be soluble in water, the NaNO3, and so it will form into the aqueous state. So we know that AgCl, or sodium chloride, will be our precipitate. Next up, we want to consider the net ionic equations. So we can write net ionic equations for solubility reactions, and so that's involving only the species that are involved in forming the precipitate. So they're essentially double or single displacement reactions in which we're defining the states of matter and the way in which they change. So we can define the net ionic equation by separating the soluble, so aqueous reactants, and products into their ions. And for those ions which don't participate in the reaction, we call those spectator ions, and they get removed from the reaction. So when we're considering the combination of the two solutions containing silver nitrate and sodium chloride, we know that the sodium and the nitrate ions don't participate in the reaction as forming a solute, as forming a precipitate, because they are soluble and so just dissolve into the solvent. However, we know the Ag ions, so the silver ions, and the Cl- ions, so the chlorine ions, combine to form the the silver chloride. And so the silver chloride, we know, forms a solid precipitate. And so because it forms a solid precipitate, we can say that that is what's going to be included in the net ionic equation. So our net ionic equation will be Ag plus Cl minus makes AgCl solid.